Hello everyone, welcome back to our course. Next, we are going to introduce Redis, which is a famous key-value type of NoSQL database. Here, we can find some basic introduction to Redis. As we can see, Redis is an open-source memory-based data structure store system. It can be used as an in-memory database, cache, and message broker. Besides, it supports data persistence and diverse data types. It also supports the calculation of set union, intersection, and complement, as well as multiple sorting operations. The typical features of Redis are high performance, low latency, diverse data structures, and persistence. And we will talk about these features just in later slides. So, we've always been talking about key-value models, but what is a key-value model? As indicated by its name, a key-value model consists of keys and values. Moreover, a key indicates a variable name, and a value indicates a variable value. It can be simply understood as a relational model. The entire database has only one table, and the table has only two fields. One for the key and the other for the value. The following figure shows a typical key-value model. The fields on the left has indexes. Therefore, you can quickly query the values on the right based on the keys on the left. Variable values on the right can be of multiple data types, not limited to values, characters, and dates, and are richer than in relational models. And particularly for Redis, the keys are always string objects. But the values may vary a lot. Namely, Redis supports various types of values. It can be not only a simple string, but also a more complex data structure, including list objects, hash object, set object, sorted set object, geographical location, and so on. This makes it very easy to solve a variety of problems because we can flexibly select the right data type for storage based on the data. So, if you want to know Redis, for now, the most important thing is to understand the basic several value types. And that is exactly what we are going to introduce next. The first data type is the string type. Strings are the most basic type of Redis. And string types are binary safe. In other words, you can use any binary sequence as a string, or you can use to save any data in a string, either a combination of letters or the contents of a JPG file. You can perform various operations on strings, such as setting the expiration time, operating byte, operating by bit, increasing byte, and decreasing byte. The maximum capacity for storing a string value is 1 GB. Redis also supports linked lists. A linked list consists of a series of elements that are sorted in the order in which they are inserted. We can add new elements at the end and tail of it. The operation efficiency of linked lists is related to specified operations. If we insert or delete elements at both ends of a linked list, the operation is very efficient, even if millions of records are already sorted in the linked list. The operation can be completed in a very short time. However, if an element is inserted or deleted in the middle of the linked list, the efficiency becomes very low. Next, sets. A set is a collection of a series of elements, which is the same as a mathematical concept. And the most important properties of sets are listed here: uniqueness and disorder. Uniqueness means that we can use sets to do deduplication operations efficiently, and disorder means that we cannot use subscripts to query data. By collecting data in a database, we can easily implement some functions, such as friend recommendation in social networks and tagging in microblogs. There are a number of things we can do about sets. In addition to basic addition and deletion, we can also perform union, intersection, and difference operations. On the basis of sets, there is a more complex data type called sorted set, which differ from sets in that each element is associated with a score. This score can be used to sort, allowing us to get the elements in the set in an orderly manner. In this way, we can sort by value and do queries and deletes by value or rank, perform various set operations on elements, and perform arithmetic operations on values. Last one, hash table, or hash in short. A hash table is a mapping table of attributes and values of the string type. An important advantage of hash table data types is that when you store data objects with only a few key values, the memory consumption of data store is small. When saving an object, if each field of the object is saved as a string character string, the space occupied is large. The hash type consumes less memory and makes it easier to access the entire object. Here, if you have not heard of hash tables before, we can give you a simple example. A hash table in Redis is similar to a two-level key-value model. The out key is the Redis key, which is just a string object, and the value of this key is another key value, which contains hash key and hash value. In each hash table, there could be one or multiple hash keys and hash values, as is shown in the example below. Now, in the first example, ID 100 is the Redis key, and name column Sam is the Redis value, where name is the hash key and Sam is the hash value. All of them together is known as one hash table object in Redis. Likewise, in the second example, ID 101 is the Redis key, while all the rest is the Redis value for the same key. And now, in the Redis value, there are 3 hash keys and 3 hash values. We hope that these 2 examples may help you to get a better understanding of the hash type of Redis. And finally, there are some application scenarios of Redis. To cache stock prices fluctuation, secure activities, real-time communications, and so on. As shown in the diagram below, we can use Redis in some secure activities. Although the traffic of the secure system is very high, the actual effective traffic is very limited. By using the system hierarchy, check in advance at each stage and block invalid traffic, which can reduce the flow of invalid traffic into the database. And here, we use browser cache and CDN to resist static page traffic. Before the set queue, a user keeps refreshing the offering details page, causing a large number of page requests. Therefore, we need to separate the set queue product details page from the normal product details page. On the set queue offering details page, static elements that can be statically processed are recommended. Except the set queue button, the server needs to dynamically determine the set queue button, and other static data can be cached in the browser and CDN. In this way, only a small part of the traffic that is sent to the server due to page refresh before the set queue. And some further strategies are implemented, such as Redis read or write separation, Redis master or slave version, asynchronous order placement, and so on. All these strategies are in order to improve the accessing efficiency as well as to enhance the system stability and robustness. Alright, that's all for this chapter. In this chapter, we introduced what is Redis, the key value model for Redis, some basic data types of Redis, and some application scenarios of Redis. Hope you guys enjoy all the contents in this chapter and see you in the next chapter.